Welcome to the What Am I podcast, a place that will challenge your perception of reality and make you question your assumptions of yourself. I'm your host, Thiago Sindra. In each episode, a guest will share what we've learned from neuroscience that explains why our mindsets can be so different from one another and why it's so hard to open up our minds for change. But we'll try to make it possible, if you're open for the challenge.
Hello, Thiago. How are you doing?
I'm doing great, Katie. How are you?
Pretty good. I'm in San Francisco right now. I've been moving around during the pandemic, but I found myself back in the city. It's actually quite dead here. Where are you right now?
I am in the peninsula, in the Bay Area, in the same San Francisco Bay Area where you are, but around like 40 minutes away from you. Is it hot there right now?
Yeah, it's been crazy weather, unfortunately, with the fires and everyone has been saying this, but 2020 is definitely the year. I don't think any of us are going to forget it. That's for sure. We're here because you're about to have a really cool conversation with someone named Dr. Addy. So he is an Associate Professor of Psychiatry and of Cellular and Molecular Physiology at Yale School of Medicine. So he has quite the background. And why don't you tell us a little bit about his background and kind of what he studies and why you're excited to speak with him?
So Dr. Nii Addy got his PhD in neuroscience from Yale University. His lab focuses on the neurobiological basis of substance use disorders, depression, and anxiety. In other words, mental health and addiction. Dr. Addy also serves on the editorial board of the journals Neuropsychopharmacology, Biological Psychiatry, Nicotine and Tobacco Research, and Neuropharmacology. He's also a grant reviewer for the Neurobiology of Motivated Behavior Studies section of the National Institutes of Health Center for Scientific Review, CSR. And now we're done. just kidding. Actually, there's more. Dr. Addy has built unique partnerships between scientists, clinicians, churches, faith leaders, entertainers, professional athletes, and community groups to address issues at the intersection of neuroscience, mental health, faith, culture, and social justice, which goes a lot along the lines of this podcast that we're building, and that's why I believe this is a perfect first episode for us. Dr. Addy also serves on the board of trustees for the Carver Project, and he also collaborated with Lecrae, a Grammy Award-winning artist and New York Times bestseller, Doug Middleton, Ellen Houston, and he also featured his work in research has been featured by NPR, the NFL Players Association, and even by Chuck Norris, which I believe makes his work indestructible. And now he is appearing on the What Am I podcast, which is an awesome opportunity we have here, and it's an honor to have him on the show.
Yeah, and we were chatting about this earlier. It's such a great time to be kind of diving into mental health. It's always been around, as we know. Sometimes it's not always normalized, though, and it's a difficult subject to talk about. But I think a lot of people are experiencing different aspects of mental health, especially with the pandemic and some other things that are going on. So it'll be interesting to have or hear like a scientific lens to what mental health is and be able to relate to it more, I think.
That's true. Yeah, that's true. I want to learn from him as well what my brain does when I am not anxious, and when I am anxious, to compare the perceptions that I have of the world, people around me, how I treat people around me, how they see me when they're anxious, etc. So I want to get into that, especially with addiction. So he also focuses on addiction, and I wanted to know how our brain reacts and behave when we have certain addiction, if addictions are the same or not, things like that. So I'm really excited to talk to him about this.
Yeah, that's awesome. And so for our listeners, if they want to learn more after they listen to this episode, where can they go to find maybe summary notes or to even share this content socially?
Yeah, sure. So you will be able to find the show notes on the app where you're listening, but at the same time, you can go to the website. Our website is whatami.show, and there you'll find, of course, more details about us, about the podcast, but you can go to the episodes section, and then you will find all the episodes that we had so far, which is only one trailer episode before this. in this first episode where you will be able to view the transcript of the episode and also get some notes on the papers that Dr. Addy wrote and contributed to, and also get some links to resources that relate to what we discussed in the podcast. Yeah.
Yeah, I know there's a lot of big words right now, especially with Dr. Addy's title. It's pretty impressive.
Yeah.
Cool. Well, with that, let's dive in. And then I'm excited to do a recap after you speak with them to kind of summarize everything we've learned and help to break down neuroscience for our audience. It's definitely a pretty technical topic. And so it'll be fun to make it more accessible.
Yeah, I'm excited to do that too. I can't wait.
Okay. Talk to you soon.
Talk to you soon, Katie. Thank you. So I'm here with Dr. Nii Addy. Dr. Addy, welcome to the show. It's an honor to have you here as the guest of our first episode.
Excellent. Thanks so much. I'm really excited to jump in, and I'm really excited to be the first guest.
Awesome. So I really want to know, why do you think it's essential to study the brain?
Yeah, this is a great question. And I always tell people that I'm a little bit biased when I answer this question since I do study the brain. But the other piece of it is because it's so central to who we are as human beings. So really the brain is what guides our actions, our thoughts, our behaviors, and our interactions with the world. At the same time, if you think back to, primary school and elementary school, when we learned about the five senses, we all know that those senses are actually managed through the brain itself too. So we also think about the fact that the brain is how we sense the world around us. And what we sense around us in our interactions with the world can actually change our brains that can further influence how we interact with the world. So it's very cyclic in that sense, but really central to who we are as human beings. Not that it's the only piece. There are other aspects of who we are in our bodies that also influence how we interact with the world. But the brain is really central to who we are and how we think about ourselves as human beings.
What brought you to neuroscience?
Another great question. And full disclosure, I always have to tell folks that my father is actually a psychiatrist. So even though I'm a neuroscientist by training, growing up, I told him I didn't want to do anything related to what he did. I guess that's that, independent nature trying to squeak through. Clearly, I wasn't all that successful at it because I'm a neuroscientist who works in the psychiatry department. But I would say, in a sense, that gave me some early exposure to thinking about the brain and how that influences people's behaviors and how they interact with the world. The other piece is I got really interested in psychology, actually, when I was in college. But I was trying to decide between a psychology major and a biology major. I was taking a class called abnormal psychology. And my professor actually told me not to be a psychology major, which I found a little bit disheartening initially, to be honest. So I was like, well, why is my professor telling me not to do this? And wondering, is there something I'm doing wrong here? But he told me to be a biology major instead. And I think what he saw was that I really had a strong interest in the biological components, so studying the biology of the brain. And so for me, that's been very gratifying over the years to focus on that. And I have looped back to think about psychology as well. So it has come full circle.
So at that time, when you chose to do biology as a major, did you already have an idea you would like to study the brain, or was it just like biology in general?
So I was thinking about the biology of the brain in particular. At that time, my school didn't have a neuroscience major. There are a lot more schools that have that now, but they did have a biology major where you could concentrate on neuroscience. So I did have that opportunity to still focus on the biology of the brain. And that was one thing I was thinking about going into the major.
So you're not a psychiatrist then?
Exactly. Not a psychiatrist, but a neuroscientist who thinks about aspects of psychiatry from a biological perspective. That's a mouthful.
Okay. Because you're in the psychiatry department of Yale School of Medicine,
Mm-hmm.
but you're not a psychiatrist. Okay.
Exactly. And that confuses folks a lot.
Yes,
As
it does.
Which is understandable.
It did with me, yeah. Since we're talking about a psychiatrist and psychologist, what is the difference between these two, or even like a neuroscientist?
Mm-hmm. So neuroscientists, I'll take it even a step back, even a little bit further, and think about the biological component versus psychology. So when we talk about biology, we're thinking about cells in our body and how they work, how they allow us to do different types of things. We have different types of cells in our bodies. We have muscle cells, we have bone cells, we have specific brain cells, and there are lots of different types of brain cells that exist. And so when we're thinking about biology, we're thinking of or neurobiology, we're thinking about those cells and how they interact with other cells in the brain and how that influences our behavior. When we think about psychiatry, often psychiatrists are thinking about things that happen in the brain. And a lot of times, psychiatrists are thinking about behaviors, but also thinking about medications that can change the brain to help people with specific challenges that they may be facing. From the psychology side of things, a lot of times that's focused more so on the behavior. So people might be thinking about specific changes in behavior, specific changes in thinking patterns, specific changes in environment that can also help people that are dealing with specific challenges. So there are a lot of overlaps in terms of what these different areas focus on, but they have slightly different ways that they approach those similar questions.
Hmm. Is it my impression, or is it right? I've seen psychologists being a little bit against psychiatrists and psychiatrists being against psychologists. And is that a thing, or is just my own perception?
Your perception is right. So that's definitely a thing. It's gotten better over the years. So there's much more overlap than there used to be. So even at the Yale School of Medicine, we have a psychology section within the psychiatry department. So there is an understanding that these are different ways to approach things. But historically, there have been a lot of arguments between the two. One saying, oh, medication, we should definitely only do medication, or we should only definitely do behavioral changes. When in actuality, things often work better when there's a mixture of both and when it's really tailored to the individual person. So some people may be in a situation where medication will be very helpful. Others may be in a situation where the behavioral changes may be very helpful. Others, a combination of the two may be very helpful. So we're in a much healthier place when we actually have those integrated conversations and don't get stuck in our own approach to these challenges.
Can we say neuroscience is the one that will get these two together and make them hug each other and then say, I love you?
I hope so. But it's funny because even within neuroscience, sometimes that becomes its own silo as well, because there's so much focus on the brain that there can be a rift even between neuroscience and psychiatry, where neuroscientists really dig deep into some of the
Hmm.
very nitty gritty details of the brain and look down on psychiatrists who might not be as focused on all the nitty gritty details. So I think just in general, we do need to be more integrated. It can even happen within psychology. People have different approaches within psychology and
True.
get stuck in their one framework versus another. So, I mean, that's probably more of a bigger philosophical commentary about how we need to be more integrated
Right.
in our approaches
Yeah.
to life as human beings. But
To your point, neuroscience can be like people can be talking a lot about the biology, right, of neuroscience,
mhm,
like how neurons work. At the same time, they can discuss very philosophical things, right? Like there,
exactly.
there are neuroscientists talking about consciousness.
Right.
Why are we behaving in certain ways, not from the perspective of cells themselves, but from how the network of neurons communicate. So, how do you define a neuroscientist? Who can be a neuroscientist?
Yeah, so you're touching on a really good point, and that is that neuroscience is very integrated. So it spans a lot of different types of scientific disciplines. So you've hinted on a few of them. There is a area of neuroscience that focuses more on philosophy. There's also an area of neuroscience that focuses on computation. So even sometimes we'll talk about the brain as a computer
Mm-hmm.
because there are certain pathways and circuits, and so people are very focused on trying to understand how these pathways act in synergy, how they interact. So there's a computational neuroscience. Some people are focused on the cells themselves. So there's cellular and molecular physiology and neuroscience, where people are trying to understand what properties in these cells allow them to be more active, to communicate with other cells. There's also an area that intersects more with psychology. So cognitive neuroscience, thinking about our thinking processes and how those actually influence our behaviors as well. So it really spans the board. And even in terms of psychiatry or psychology, there's a neuroscience component to both of those, whether it's talking about medication and how that changes the brain, or whether it's talking about a behavioral change or intervention that also changes the brain to get to the same outcome.
It's interesting to think about this. Like I know, like Patricia Churchland, I think it's one of the main neurophilosophers today. There's neurotheology as well.
Yes. Yeah.
Andrew Newberg has like a lot of studies in the area. There's neuromarketing,
Mm-hmm.
like used for
Yep.
how to improve marketing using neuroscience.
Yeah.
So just to step back a little bit, talking about your research, you work in a lab studying psychiatric disorders, correct?
Correct.
But before we talk about that, what is the best or like the correct way of saying, is it psychiatric disorder, psychiatric illness, mental disorder, mental illness, mental health?
Yeah, that's a good question, and it's a bit of a moving target as well. But I think we have gotten better in some ways. So, one of the general principles that we often talk about within the field is making sure that we talk about these illnesses as a component of what people are struggling with rather than defining who they are. So in the same way, if someone is struggling or has had a stroke, we don't say that person is a stroke. I mean, that doesn't even sound right.
Right.
But sometimes we do that with other illnesses. We say, oh, that person's a diabetic or that person is a schizophrenic. And so we're trying to move away from that. It's much more appropriate to say that is someone who's struggling with diabetes or that is someone who has schizophrenia, because that's a component of them, but it doesn't define who they are.
Right.
So that's one, I think, really helpful change that we've made as a field to really think about people as whole people and not define them by specific illness that they're struggling with. But I think we do also acknowledge that these are illnesses. So when people are dealing with mental health challenges, they are also illnesses. I think that also helps to fight the stigma, because if we can say this is an illness that someone has, there's an aspect of something that they're trying to overcome and move through, rather than saying, oh, this is something that defines them, this is something that's horrible about them, which isn't anywhere close to being true. But it's very easy for us as a society to try and put people into those bubbles or categories and look at them in a negative light.
Mm-hmm. So in that sense, is it okay if I just use psychiatric disorder from now on?
Yeah, that's totally fine.
Okay, so how do you classify something as a psychiatric disorder?
Yeah, and that's another good question as well. So one thing that we often try to highlight from a neuroscience perspective, also from a psychological perspective, psychiatric perspective, is that a lot of the challenges and disorders that people struggle with are on a spectrum. So it's something that a lot of us will deal with. So a great example of that is anxiety. So I think we can all think about times when we've been anxious. More recently, COVID is probably a very unique situation where, on such a global scale, so many of us have had to deal with the unknown and the fear of the unknown and all of the anxiousness that comes with that. So every human being can relate to being anxious in some shape or form. The question becomes, when does that really become impairing to that individual's life? And that's when we tend to start to classify things as illnesses or disorders. So again, with the anxiety, a helpful way sometimes to think about that is the difference between worry and anxiety. So worry, a lot of times we'll talk about that being tied to a specific event or a specific situation. So if someone's having an evaluation with their boss, they may be worried about going to work that day, feeling a little bit uncomfortable because of everything around that. When we think about anxiety, often that's more of an impairment. We might talk about that being excessive worry that gets more globalized. So if we go back to the work example, someone who is worried about that interaction with their boss, but now is anxious just every day they go into the office, every day they talk to an individual, it becomes much more all consuming and impairs their ability to kind of have a normal functioning day to day. So that's where things start to shift towards a place where we'd say this is impairing someone's day to day interactions, and something that's we're shifting towards more of an impairment and an illness that we want to try and address. But again, all of us can experience that in some shape or form along that spectrum.
So that's an interesting definition, because you're saying that when that becomes impairing to that person, then we can classify that as a psychiatric disorder. But in the sense where the person is not being impaired, but is impairing others. So, for example, for me to be diagnosed with anxiety, I have to be going through, like, this has to be impairing me so much. I'll go to the doctor, then I'll talk about what I'm going through, and then I'll be diagnosed with anxiety. But if I don't know I have anxiety and I'm impairing a lot of people around me, like, for me, I'm not being impaired. In my point of view, I'm just okay, right? I don't even know I have anxiety, but all my behavior suggests. So
Mm.
especially the people around me who are being affected. How is that classified? Is that also considered a disorder, even though I don't consider that?
Right. So there's a few different ways I could answer that. So I'll answer first as from a neuroscience perspective. So from a neuroscience perspective, I would say that that would still be, if we're thinking about what, I'll actually even narrow that a little bit. So maybe a neuroscience perspective, thinking about the brain biology that might lead someone to act in an anxious way more often than not. So from that standpoint, that would still be considered within that category of being an impairment or disorder. But taking a step outside of that, and this is a part, I'm not a psychiatrist or a psychologist, but there can be a difference there in terms of if that's not having specific effects on the individual, then that might not be considered an illness.
Mm-hmm.
But actually, the way you ask that question brings up a really important point and a challenge for the field, because we really don't have a good sense of the biology underneath a lot of psychiatric illnesses. And in some ways, it's the categories that we've drawn without knowing what that clear sense is.
Right.
So, for instance, we might say that someone's depressed, but we've put a lot into that category. Some people who are clinically depressed, and I've heard colleagues talk about this, will sleep a lot more. Other people will sleep a lot less. But that's still all under the umbrella of depression. The question is it really the same underlying illness that they're dealing with, or the basic biology, or there are two different things that are leading to what we all lump together as depression? And on top of that, if it is two different things and we're trying to treat them the same way, are we missing something and treating someone in a way that's not actually going to be helpful for them, because we've now taken two different situations, lumped it into one, and tried to move it forward? So your question really hints on, or touches on, one of the struggles that we have as a field, which is really trying to clearly define what we are talking about when we're trying to help people move through these challenges.
Right, which is not wrong to create categories, right? But
Mhm.
they can be harmful, but they can be helpful at the same time.
Exactly.
Dive into your research a little bit. Tell me what you do, what type of work you do in the lab.
Right. So the lab in particular, we do a lot of work using rodent models, using rats and mice. And basically, one of our first and main questions is to understand the processes in the brain that guide our behaviors. And we can do that from the animal kingdom all the way up to humans. So as a basic neuroscientist, that's a piece that's intriguing to me, trying to understand like what's happening in the brain that allows us to have cravings for coffee. Maybe that's too much of me telling about myself,
And me.
but those are the types of things that we think about. On top of that, we also think about psychiatric illnesses, like we've said, and we think about specific behaviors that are associated with psychiatric illnesses. So, someone that's struggling with substance use, we think about, well, what are some of the behaviors that are associated with that? So, relapse behavior, craving, withdrawal, someone who's struggling with anxiety, someone who's struggling with depression, thinking about all those behaviors and trying to understand what's happening in the brain that's allowing those behaviors to emerge. So if we can get a sense of what's happening in the brain that allows the behaviors to emerge, we might also get a little bit of a sense of what is actually underlying the psychiatric illness itself. So if we can get to that point, we may be able to make changes in the brain biology to decrease the symptoms associated with this illnesses. So decreasing craving, for instance. We won't touch the coffee craving because I like that craving, but maybe other types of cravings, or decrease, the anxiety that people are feeling, or decrease the lack of motivation that people feel with depression, and to help people move through those challenges to get to a better mental state.
And how do you do these findings? I assume you don't ask the rats, hey, are you feeling anxious? Are you depressed?
Yeah, that's a great question. That's one that always comes up. So we can't ask the rats those questions specifically, but we can design behaviors that let us get a sense of how they might be acting in specific situations. So rats, for instance, they like to be in the dark. They like to be in comfortable places. So one of the things we can do is we have a maze that's elevated about 40 centimeters off the ground. So not anything that's dangerous, but there are two closed arms and two open arms. So the animals prefer to be in the closed arms. They feel more comfortable there. If you give the animals an agent that heightens anxiety, they'll spend much more time in the closed arms. If you give them an agent that decreases anxiety, they'll actually spend more time exploring in the open arms. So we can use that as a metric to kind of get a readout for how the animal, not that we know how it's feeling, but we let its behavior tell us a little bit about its feeling. Similar thing we'll see, The rats, like us, they like things that are sweet. So we'll give them access to sugar water. If they're in a more motivated state, they might work more for that sugar water. If they're not motivated, they won't work as much. So there are tests that we can do. We have certain models that we've found that we know certain changes in the brain can make people more depressed. And the animals will show similar things where they won't engage in some of those, what we would normally consider rewarding behaviors when they're in that state. So it really gives us a window to really kind of tap into what's happening in the brain that allows these behaviors to change. Similar with the substance abuse, the animals will actually take drugs that people will take. So nicotine, cocaine, amphetamine, and heroin. And if you take the drugs away, they'll go through periods of withdrawal. They'll also show relapse behavior. So again, we can kind of see what's happening in the brain when they're engaged in those behaviors. And it gives us a real sense of the kind of the intriguing biology that underlies some of those behaviors.
Mm-hmm. Yeah, I was gonna say it sounds like you're describing me when you talk about the rats, like talking about the sweets and like being anxious and going out and then like crossing this this maze. So how is our brain similar to the rats? Why would we choose mice and not other animals?
Yeah, that's a good question. And sometimes when I tell people those studies, then they say, "Are you telling me I'm the same as a rat?" And no, not exactly. But I am saying that there are similarities there. So one of the things that makes us human that we talk about is what is our quote unquote higher order thinking, which really refers to some of our planning, decision making that happens in the area of the brain. The front of our brain is called the prefrontal cortex. So the rodents have that also, but it's not as developed as ours. But there's enough similarity that we can still study some of those areas to get a sense of what happens in humans. So, for instance, those centers are also important for our emotional regulation. And when we're looking at things like relapse, we can see similarities between what we might be able to do with specific techniques in the rodents to look at maybe decreases in activity in some of those areas that allows this relapse behavior to occur. And then we can also do similar studies in humans. These are much more expensive, but sometimes we can do imaging studies in humans that give us a little bit of a sense, not with the same level of resolution as a rodent, but shows us similarities in the humans as well. So to be able to look in similar brain regions, starting in the rodents, where we can be, much more detail oriented, focusing on the cells and the biology and some of the activity, and then make a correlation to what happens in humans, has a lot of power because of the similarities between the rodent brain and the human brain.
And how does your research contribute to the understanding of psychiatric disorders and addiction? What are the results from your studies?
Yeah, that's a great question. So one of the things that we're really excited about is we've been able to basically identify specific chemicals in the brain, specific chemical messenger systems. It's one way that the brain cells talk with each other, and to see what those messengers are doing during periods of relapse. So during periods of relapse, there's increases in certain chemical messengers, one of those being dopamine. And you can see that when the animals are exposed to cues that remind them of the drug. So going back to my coffee example, if I walk past a coffee shop or I smell coffee, that you may be able to relate to this, but there's a certain feeling that comes over you. There's a certain craving.
Yes.
And so basically in the animals, we're able to see how their brains respond when they had those cues associated with drugs. And dopamine seems to be critical for that. So in some of our work, we've been able to alter that dopamine response to decrease their craving behavior. And so for us, that actually has been pretty informative because we've been able to use some specific medications that are FDA approved for other things like hypertension, but that also have effects in the brain. So now we're able to take those studies and now to apply them to a human study where we can bring in individuals who are struggling with substance use disorder and say, if we use this FDA approved drug, will this also decrease drug craving in these individuals, and do brain scans to see whether that's also happening in some of the brain regions that we've identified in our animal studies. So it really allows us a way to translate what we find in the animals to a human condition and maybe think about new therapeutic interventions that could ultimately decrease craving and help people who are trying to stop using drugs.
Just to try to clarify a few things.
Mm-hmm.
When you talk about dopamine as a neurotransmitter, when we say dopamine is the reward neurotransmitter, because the neurotransmitter itself is responsible for doing something, but where the neurotransmitter is what is responsible for either the reward system or something, right?
Exactly.
So the neurotransmitter itself doesn't do anything. It's just like a chemical, right? That in the right place at the right time will cause certain effect. Is that assumption correct?
Yeah, because it's just one player in kind of the masterpiece of what's happening in the brain. So yeah, if the neurotransmitter concentrations are increased, it's also going to act at specific areas, as you mentioned, in the brain, and specific targets. So one of those targets that we talk about, they're called receptors in the brain. So those receptors, the chemical will actually bind to these receptors, and it'll change the activity of those cells in those specific areas. So some of those, the other thing about dopamine that's helpful for people to know is that dopamine is also very important for movement. So when we talk about things like Parkinson's disease, those are the cells in the brain that actually die over time that make it difficult for people to move. But there's an interesting piece where it's also tied to emotion. So there's an area of the brain that is at the interface of emotion and movement. So basically, it responds to emotion and can translate that emotion into different actions. So again, going back to our coffee example, when I have or when you have that craving for coffee, often that translates into some type of action that is actually going to buy that coffee, make that coffee, whatever the case may be. But again, dopamine can be acting on those receptors to lead to a whole host of downstream effects that actually influences our goal-directed behaviors. Now we're moving directly towards that goal of getting coffee. For someone struggling with substance abuse, that can be the drug itself. I've heard, we've had people who are struggling with substance abuse talk to our students sometimes, and they'll say when they get that craving, it's like having a craving for your favorite food, but multiplying that by 1,000.
Wow.
So just giving you a sense of how powerful some of these processes in the brain can be to really change people's behavior. But it's a great question. You're exactly right. It's just one piece of the puzzle.
Right. I wanted to clarify because of what happens sometimes is on the internet, you can find everything, right? You can find news with awesome headlines saying how certain scientists found out that dopamine can make you smarter, for example. And then chocolate gives you dopamine, and then you eat a lot of chocolate. So it's not like chocolate has dopamine itself, right? It's just the pleasure of doing something that triggers the release of this dopamine.
Exactly.
That aligns all these behaviors, right, to achieve certain goals.
Right.
So in that case, it just came to mind now as well, like one of the trending things happening, especially like in the Silicon Valley, the dopamine fasting.
Yeah.
You probably heard of that too.
Yep.
Yeah, because
I had a feeling you were going there.
Right. I didn't want to go, and then I just thought about that because I am in the Silicon Valley, but I don't I'm not adept to that. But this is some of the things that causes these huge headlines in these news articles all the time. Like, you can just do this and your levels of dopamine will be much better. So you can, I don't know, fight depression or anxiety by whatever, eating broccoli. So it's not as simple as it seems, right?
Yeah, I would say a lot of those things are well-intentioned, but oversimplified.
Right. When you talk about anxiety, you talked about dopamine, but what is the role of serotonin on that? Because reason I asked is I have anxiety. I don't know. Am I violating my own HIPAA with that?
No, it's totally, you have the power of self-disclosure. So.
Right. Okay. So the SSRI that prevents serotonin to going back to the neuron, making more serotonin available in the synaptic cleft there, that helps alleviate my symptoms of anxiety. And then I coped very well. But this whole time, I'm just hearing serotonin. But most of the times going through your research and your papers, like I read dopamine and anxiety and depression. What's the relation or what's the difference?
Yeah, so that's a great question too, because they are involved in some overlapping brain regions, but they're also involved in different brain regions. So this actually touches on a point that we often don't talk about explicitly outside of neuroscience circles as much as we should, but just the homeostasis, to use a scientific word of the brain, basically meaning the brain is always going to try and get to a state of stability. So there are lots of different ways that you can perturb that. So there are several different neurotransmitters and chemicals in the brain. And if you alter any one of those, they can have consequences in a lot of ways. So there's lots of different hypotheses, for instance, about depression or anxiety. Some is based on serotonin. There are hypotheses based on dopamine. There are others based on another neurotransmitter known as acetylcholine. And a lot of these neurotransmitters act in similar parts of the brain. So if one can be adjusted and that gives alleviation, that's great, but it doesn't mean that that's the only cause, but that could help in a sense reset the system.
Right.
This also goes back to the point that we talked about earlier, in that anxiety doesn't look the same in each person when we think about behaviors. And it also wouldn't look the same for each person if we think about the brain. So for some people, there may be changes in serotonin, and the selective serotonin reuptake inhibitor is effective. For others, those medications might not be that effective. A different medication might be effective. And that can depend on people's biology. It can also depend on people's experience and how that influenced their biology. So there's so many different components.
Right.
But to your question, the dopamine and serotonin are interacting and intersecting in specific brain regions, and they all affect how the brain acts as a whole. Again, if we think about this aspect of it acting as a computer, you can disrupt one piece. I mean, anybody who's had a computer act up on them, it's usually one thing that then causes a lot of different problems to occur. But there can be, the challenge is figuring out what is that one thing that actually caused this in the first place. And that's not always a straightforward answer. Similarly with the brain.
So in that case, I would assume as well that genetics play a big part on
Definitely.
that, right? Because I can have a brother who has not almost the same brain because we're not twins, but like my brother and I, we have similar genetics, but at the same time, it's different, right? So he can inherit certain genes and certain traits that will make his brain produce more receptors, let's say, in serotonin receptors or something. And then I have fewer. In that case, the same medication would cause different effects, right?
Yeah.
And this is one, I'm just talking about like this, only like the number of receptors, but there are like many other things, right? And there's other types of cells. Like that's a lot.
Yeah, definitely complicated, which is one of the challenges that we face as a field too, because there's so many different components and pieces where things can change and have consequences.
Yeah, that's why I wanted to have this podcast, because it's not as simple as it seems when we think about the brain. I mean, everything in life is not as simple as it seems, but the brain seems to be one of the most complex things that we are still trying to figure out how it works. And when people say there is a startup that found that this technology they use when you put on your head will change the symptoms of depression, but that is a technology that may be only working in 12% of cases for certain people of certain age, certain sex. And this is not a general thing. But for someone not involved in neuroscience, they look from outside as like, wow, this may be the thing. Like I need to buy this one, right? And then it generates even more and more news around the topic. Then there's more and more people. What do you think about that?
I mean, when I hear those stories, I'd say there's a lot of onus on us as neuroscientists to make sure that we're still engaged in those conversations and clearly communicating the effectiveness of different options so that people have a real understanding of how effective some things are or aren't. Because, I mean, it takes people doing their homework too. I'm not going to say that it's only on us, but I think we could do a much better job as a scientific community in general of really communicating those things clearly.
Right. Yeah. Expecting everyone to do their homework is not going to be very easy, especially 2020 is proving that is not very easy. I was going through your latest paper on the acetylcholine and the muscarinic receptors, right?
Yes.
So now we're talking about a third neurotransmitter. We talked about dopamine, we talked about serotonin. Now you, from my understanding, what you're saying is like you're studying the role of this other neurotransmitter called acetylcholine that acts in one specific receptor.
Yes.
That causes another effect on the dopamine system. So it's not like directly like acetylcholine is giving you more or less anxiety or more or less depression. It's basically acting on a receptor that triggers this whole like release of dopamine in the system, right?
Right, exactly.
Something like that.
Yep. Yep, exactly right.
Okay, so in that sense, why is it important to study that specifically and not get your lab to study and research dopamine or the dopamine system?
Right. So there were a couple reasons that we decided to start to focus on acetylcholine. One of those was because of some of our work that we were already doing with substance use disorder. So there we had found that the acetylcholine system seemed to be very powerful at regulating the dopamine system. And this wasn't something, we weren't the first people to look at that. Others had looked before, but it hadn't really gotten that much attention. So it's actually a paper from 2008, and I think the title is something like Acetylcholine, the neglected master modulator of dopamine signaling. So for whatever reason, it just wasn't garnering that much attention. We're 12 years past that, and I think things are changing a little bit, but still, for whatever reason, that's the case. But in 2013, there were two papers that came out that looked specifically at the dopamine system, and they were using a technique that was pretty new at the time called optogenetics. So basically, with that technique, you can manipulate cells in the brain and use light to either activate or inactivate or turn down the cellular activity. And what they found is when they did that, and specifically in dopamine cells, that had what's known as a causal effect on behaviors associated with depression and anxiety. So depending on the type of test you're doing, you can either induce or promote a certain depressive-like behavior by turning on or turning off those cells. So we were looking specifically already at how acetylcholine regulates that dopamine activity. So basically what we said is if that dopamine activity is central to some of these behaviors, then you would think whatever is regulating them would also play an important role. So that was the first piece. The second piece is we went back into the scientific literature, and there is an acetylcholine hypothesis of depression that goes back to the 1970s. This is something that was pioneered and put forth by Dr. Janowski. And basically what they found is that there were a lot of people that were using pesticides, so organophosphates in pesticides that actually act on acetylcholine in the brain. And they were finding out that people who were exposed to those were showing a lot of depressive symptoms because basically it was allowing them to have much higher levels of acetylcholine in their brain. And that was leading to all the types of things that you see with depression, which led Dr. Janowski and others to come up with this cholinergic hypothesis of depression. So we basically put those two ideas together. There's already a hypothesis around it, and we know that it can regulate certain neurons, dopamine neurons, that are important for this. So it made sense as a very important thing to look at and to say, one, is it involved in some of these types of behaviors? And two, can we actually develop medications that can target the acetylcholine system and maybe decrease some of the symptoms associated with anxiety and depression?
But going back to one of the previous points we talked about, where the neurotransmitter can be found in many places in the body. Mm-hmm. So acetylcholine, from what I know, mm-hmm. it works in the neuromuscular junction as well, right? Exactly. So the more you have, or the less you have, like you end up affecting your movement, right?
Right.
So now you're talking about acetylcholine in the brain. Mm-hmm. So that's why I was saying before, like you cannot just like think, okay, I'll do something that releases acetylcholine or makes more acetylcholine available in my body, but then it's affecting everything, right? Mm-hmm. Not just your brain. So how do you target specifically that area, that region in the brain?
Yeah, so we were very fortunate in that. So another important point is we had talked about the receptors that actually respond to neurotransmitters, to chemical messages in the brain. And there's also different types of those receptors. So even for acetylcholine, there are slight changes in those receptors, and there's basically a class of them. So they've been classified as, so with the muscarinic system, which is a type of acetylcholine receptor, there's M1, M2, M3, M4, and M5. And those are located in different regions in the brain and different parts of the body. So fortunately for us, we've been able to look at ones that are specific to the brain and specific to certain areas of the brain. So what we've decided is to focus on those and to see whether changing the responses of those specific receptors can influence anxiety and depression behavior without influencing other types of behavior and without influencing what happens in our muscles as well. So that's not always the case, but we were fortunate in this instance to find a subtype that was pretty localized. And we were also able to collaborate with other investigators at Vanderbilt University, Jeff Kahn and his group, who developed agents that specifically target that subset of receptors. So, I mean, that again shows kind of the integrated aspect of neuroscience, where we're working with chemists who are doing this and thinking about different ways to really move things forward. But it's a great point. And if if that hadn't been the case, then these things wouldn't have moved forward, because we can't have something that's going to cause a lot of muscular changes or changes throughout the brain that are going to lead to a lot of side effects.
Right. Optogenetics itself, it's a topic that we could talk probably about like for hours, how someone came up with that idea to specifically just trigger that neuron or specific neurons to fire based on light in your brain.
Yeah.
Wow. Moving on to addiction, you talked about your studies in addiction as well, how acetylcholine plays a part in that. First of all, I believe you mentioned that already, like how addiction, like someone is not an addict, someone has a substance use disorder, that would be more appropriate, right?
Yes.
To say. Why is that considered a disorder, first of all?
So it's similar to what we talked about when we were talking about anxiety in terms of impairment. So when people are diagnosed with substance use disorder, there are 11 different symptoms that are associated with that. Some of that and one of those is withdrawal that happens if people stop taking the drug. Another one is craving. Another one is people continuing to use a substance despite wanting to quit, or continuing to use a substance despite the negative psychological consequences or negative physical consequences. Being preoccupied with using a substance instead of being involved in daily activities. So there's lots of different consequences that can have for that individual. And oftentimes that will be categorized either as mild, if there's 2 to 3 symptoms, as moderate, if there's 4 to 5, or as severe, if there's 6 or more. But the basic framework, again, is similar to an impairment that occurs in the individual's life, where they're not able to engage in their daily activities and is having consequences from that standpoint.
Does the level of addiction, like as you said, what were like 1 to 3?
So 1 to 3 symptoms would be considered mild, or 2 to 3.
Mild.
Yeah.
2 to 3 is mild. Okay. So how do you differentiate that? Is only based on the level of impairment, or does the source of the addiction also is taken into account? For example, if I am addicted to cocaine versus addicted to coffee.
Yeah, so that's a good question. That's still debated. So a lot of this comes from at least in the United States, comes from the Diagnostic Statistical Manual, DSM-5. Internationally, there's another document that people use, the ISD-10. And those pieces are still debated. So you hinted at an important piece here, because there are certain things that people can show some of these behaviors towards that could be considered addiction-like, but those aren't necessarily categorized as addictions in the DSM. So we'll often talk about behavioral addictions, and Mark Potenza, one of my colleagues at Yale, focuses on this in particular. So that can include things like gambling, include things like shopping, internet use, video gaming. But from a DSM standpoint, the only behavioral addiction that's categorized in that document is gambling. Whereas a lot of these other things have similarities, but haven't been classified that way yet. Eating is another one. And even from a brain perspective, sometimes we see overlaps in terms of what's happening in the brain when people are struggling with substance use disorder for a substance versus, excessive eating. Sometimes there's similarities that occur there as well. So that's definitely an ongoing conversation that you're really touching on with that question.
Do you think that could change? It could ever go into the DSM?
I do think it could change.
What is necessary for that to happen?
Those are committees that meet together and kind of talk through the different symptoms and the ways those things are characterized. And I don't remember how often they meet, but it's every few years. And that has even changed because different substances have been added to those categories over the years. And the ways that things have been categorized have shifted as well.
In terms of what happens in the brain, what would be the difference between my addiction to, let's say, Facebook, Instagram, TikTok, whatever, and cocaine, heroin?
Yeah, so I can talk about that a little bit this will sound funny, but from the animal perspective, not that we've created any Facebook sites for our rats.
Right. No one does it, right?
At least not yet.
For the cats, maybe.
Yeah, that definitely has happened. But there are differences in the magnitude of the effect sometimes. So some studies have been done with that, for instance, say drugs of abuse versus natural rewards like food or sex or things like that. So basically, oftentimes we'll say that the drugs of abuse, quote unquote, hijack the reward system because you do see increases in dopamine when people are eating a food they enjoy or when the animals are eating a food they enjoy. But if you give that animal cocaine, you see a much greater increase in dopamine. So it's quote unquote supra physiological, so much higher than you would see with something else physiological. So even though we haven't done those studies in rats with Facebook or TikTok, I would imagine that that same principle is there in terms of substances of abuse having a much higher effect. But the other piece there is that you do have changes that happen over time. So if you have continual conditioning or continual use of a specific thing, you can see increases occur, not only to the thing itself, but sometimes to cues in the environment that are associated with that. So one example, this is going back to substance use disorder, but I always give is nicotine and smoking. So someone who always smokes whenever they go to the bar, over time, what is happening is that just being in the bar is leading to increases in dopamine that's then leading to craving. So someone says, okay, I'm going to stop smoking, but they keep going back to the bar. It's very unlikely that is ever going to occur because those cues are now acting in the way that the nicotine used to increase dopamine. Now the cues are doing that. So that makes it very difficult for people to move forward. And that's why sometimes being in a different environment can be so effective. Because your brain has changed being in that environment and having that pairing happen continually. Sometimes you need a shift in that environment, if it's possible, to make those changes. And there are other ways to do that too, but that's just one practical example.
Yeah, I have this hypothesis. I always joke that how it is so hard to go to the gym and work out, but for me, it's so good and so easy to eat ice cream or like drink some milkshake. So I was thinking, what if I go to the gym to work out, and right after that, my reward is to have like a huge ice cream, and pairing both together. So when I go to the gym, like I feel good without having the ice cream, or maybe I'll just like I don't know, get strong by eating ice cream or something. But
if you do, let me know.
yeah,
I'd like to know about that.
right. I will. It hasn't happened, but one day maybe. We first talked about genetics and mental disorders, how I can be more susceptible to certain disease, but can I be more susceptible to addiction? Can I be genetically prone to get addicted to any drugs specifically?
Yeah, that can definitely happen as well. So I don't know. I don't focus on alcohol research particularly, but I do know that there have been a lot of studies looking at that with alcoholism, for instance, and looking at susceptibility there. So what people can do with genetics is actually differentiate how much of the susceptibility is due to genetics versus other factors. And that's definitely something that people have done when thinking about alcoholism. The challenge with some of those studies, so for instance, if someone grows up in a household where a parent is struggling with alcoholism, it's much more likely they will as well. Some of that's genetic, but some of that is also environmental because you're exposed to that behavior and to the alcohol in that environment. But there are studies that people have done to try and tease that apart. And sometimes those are done with twin studies as well. So comparing twins to families where individuals aren't twins but are still biologically related, because you can get a better sense of the genetic component. But there's definitely a susceptibility that's there as well.
So how much then can I control? Like I don't want to go into like free will and like this huge discussion we could have, but how much can I really control of my addiction, for example, versus someone who doesn't have any problems with that? How can I just say it was not my decision to become addicted to alcohol or something when the others are actually blaming me for my addiction? How much can I control?
Yeah, that's a really good question. So I'll answer that by with a story. So a few years ago, I was giving a talk in a public library, just talking about the neuroscience of addiction was what the title of it was. And so there were folks from the community who came to that. We also had some folks who were recovering from substance use challenges and were in a recovery house who came to talk. And it was interesting hearing their perspectives, because when they first got there, they were interested in the topic, and they said, "Oh, I don't really see this as an illness because this is something I did to myself." So there's a level of truth to that, right? Because even with the susceptibility, you can't become addicted to a substance if you never use it in the first place. So there has to be some level of volition that has to happen, just practically speaking.
Okay.
But at the same time, once you've used, there are also different factors that come into whether you're going to be a casual user, or whether you're going to or whether you're going to be someone that is going to struggle with substance use disorder. And that can be due to a lot of different factors. That can be due to people's specific social situation, to stress levels in the home or different things, or also this genetic susceptibility. So the question you asked isn't necessarily an easy one to answer, but it's one that there are that there are multiple components that contribute. Because yes, in some ways, and I keep going back to this, this coffee example, because that pairing has happened so often, the craving is going to come when I walk past a coffee shop.
Right.
But there are also ways and interventions that can be decoupled. So there are ways that I can learn new behaviors that might make that less likely to occur. So it's a little bit of both. It doesn't mean that I have no control, but it also means that it's not necessarily easy, and there's an element of change that will have to happen. And there are elements that happen as well. That conversation has become very interesting over the years, in terms of how much control do people have or not have, and it even starts to touch on some of the systemic ways that we've set things up as a society. So Carhart wrote an interesting Neuron paper about that, and how drug use is interpreted differently in racialized contexts, and how that can actually be interpreted or used inappropriately by the police in certain situations. So there's a whole nother level of philosophical conversation that comes with that as well. But it's a huge question, but a really important one.
You just touched on this point about racial injustice, and with everything that is going on right now, how does the current social injustices that are happening, that always happened, but now it's being more widely talked about, how does that affect mental health?
Yeah, there's definitely an interaction there as well. So just to quote the Anxiety and Depression Association of America, they've highlighted this as well, that all these racial injustices can make it much more difficult for people. And, seeing these injustices of people who look like you in particular increases people's susceptibility for challenges with anxiety and depression and other mood disorder challenges, as you might expect. But not even for people seeing folks who look like them who are suffering, just in general, it's just putting a lot of us in a heightened state of susceptibility. And on top of that, you add COVID, which is also doing the same thing. So it makes for a really challenging season that we're all walking through.
Yeah, that seems like a lot. Yeah, I remember when COVID started happening, we were quarantined, and we were already like not believing COVID would take forever and we'll be home like for a long time. And all of this discussion we were already anxious about, and that's when we saw the unfortunate killing of George Floyd and how everything turned out. And I want to go out and protest. How can I go and do something about it when at the same time there is this pandemic happening, and then like I believe Black people suffer even the most? So how can people deal with fear, anxiety, and everything that is going on right now?
Yeah, that's a great question, because it's such a huge challenge as well. And one thing I should have also mentioned is just kind of the trauma that comes with the repeated cycle, and seeing the cycle continue to happen over and over again. Because unfortunately, as we all know, George Floyd wasn't the first and not the last. And so there's kind of the re-traumatization that continues to happen that makes it even that much more difficult for people. But one of the things that's been important, and this actually even falls back into the neuroscience conversation we were having, is just the importance of community. So that was highlighted with COVID. It's been highlighted with some of the racial injustices, and just the importance of community in helping us from a standpoint of resilience. So from a neuroscience perspective, we know that we can see that in the rodents, that when the animals are in community, that actually changes their brains and makes it less likely that they'll deal with some of these behavioral pieces that we're talking about in terms of aspects of behavior associated with substance use or anxiety and depression. It's not 100% protective, but it's less likely for those things to occur. And it also helps the animals, or it helps people also move through some of those challenges. So even when we were going to COVID and people had to stay in their homes, a lot of things that psychologists were encouraging folks to do was to stay in community in some shape or form, like we're doing now with this call, with Zoom, texting, FaceTime chats with family and friends to really keep that sense of community. Because I think a lot of people were realizing how central and important that is for our day-to-day mental health. And the same thing with all the racial injustices. I mean, for me as a Black man in the United States, it's been very powerful to see other people, not just Black individuals, stepping up and denouncing the racism that's occurring and walking and marching together. And that has effects from a neuroscience standpoint as well. So that community actually will have protective and important effects on our brains, can change our brains. And so that's only one piece of it, but that's something that's critically important to really dealing with all the things that we're dealing with as a society right now.
Yeah, I like you mentioned that because I was going to talk about that specifically, the community part on Twitter. I remember when I think it was a white woman actually asked about the Black in Neuro hashtag, if there was anything existing that could bring together all the neuroscientists who are Black. And then like people were saying, no, actually we don't, I don't think there is anything like that yet. And then like they created this hashtag and then became like a group on Twitter, and then finally became like this website.
Yeah.
And now like this is amazing. Like the website is awesome, like has a lot of like events going on. You have profiles of a lot of neuroscientists, and that is actually how I found you, right? Like on blackinneuro.com, if I'm not wrong, right?
Yeah, exactly.
And for you, how do you live with community? Is it the school? Is it family? You have friends you call? How do you exercise this community?
Yeah, so for me, it's a little bit of everything, to be honest. Because there are lots of different communities that I'm involved in. So some of that is the Yale community, so the folks that work in the lab with me. So especially when COVID hit, there was a lot of checking in with them as well, and making sure that we all were kind of looking out for each other and, looking forward to that time. I've also done I was on sabbatical from January to June. So that also gave me a new community in a sense, because I was going through some didactics and classes with some of the clinical psychology interns in New York Hospital. So that was another subset of community. There's also family that I have that's spread out throughout the country, throughout the world. And then a lot of just colleagues that I've, walked through with over the years in training, and especially with all the racial injustice that was happening,
Right.
Colleagues of all races, but then also having Black colleagues that I kept in touch with, because of the way that we could talk about some of the similar things that we were feeling with these things. I'm also involved in a faith community as well. So through a Christian church, and being involved in, again, those same types of conversation with those folks, and sharing struggles, sharing joys, and just knowing the importance of that community, and having some of these same types of conversations in all those communities across the board to say, how do we support and encourage one another as a joint humanity to really help us move forward into a much better place than we are right now.
Nice. Yeah, that's a good point, and could be a good challenge as well. We'll talk about that in a minute. My last question to you is: are there more people anxious nowadays? Pre-COVID, like COVID, yes, I'm sure like everyone is anxious. But before COVID, were there more people anxious, or we just started diagnosing people properly more often with anxiety and noticing this more?
Yeah, that's the $1 million question. So I would say, I actually think it's a bit of both. And that's my opinion. So I do think we are getting better about diagnosis. And I would say some of that is positive, because in a sense, we're helping to decrease the stigma. Whereas before, people just people would say, oh, that's the crazy person over there, or that's the person who's always doing this or always doing that. We would just dismiss it. Whereas now it's not where it should be, but there's much better conversation about, no, that's someone who needs to get help. And we are doing better about making that available to people, it's still not as good as it should be. And, there's reasons behind that. But I'd say the diagnosis is happening more often. But at the same time, we are also, as a society, probably more disconnected than we think we are. So, people speculate about whether that's, social media and people feeling connected and feeling like they have friendships where the depth of those relationships aren't necessarily as deep as they would have been in person. And the research keeps moving. Some studies come out and say, oh, the more time people spend on social media, the more anxious and depressed they are. Oh, the more time people spend on social media, the more connected they are, or there's no difference. So that's still a moving target. But I think in some ways, there is evidence that we're not as connected as we think, just because we've tweeted something at someone, or we've chatted them, or they've liked our Facebook post. That's not the same depth of connection as actually being face to face or screen to screen, as it may be in this moment. But
totally true. Do you have a challenge for us, for the listeners?
Yeah. So I would actually tie it back to some of the things that we've talked about our shared humanity and our shared experience of anxiety. So I think one thing we can all do, and something I've been doing as well, is just trying to think back about times when we do feel anxious and to pay attention to what is actually triggering us to feel that way. So is there a certain situation or a certain time of day or a certain event where we're more likely to kind of have an anxious response? And unfortunately, for a lot of us, that's much easier to do right now in the midst of COVID because of all the stresses that are going on with that. So my challenge would be to say, when you start to feel those times of anxiety, which will undoubtedly come, to really think back about what caused that. And also to give yourself time to see when you're able to move maybe from that state of anxiety to a more thoughtful or calm kind of response. Because from a brain standpoint, there are different processes that are involved. So some of our emotion areas are really heightened when we get into an anxious state of mind. Sometimes later on, we might realize, oh, I didn't really understand that situation. Maybe I overreacted. It wasn't as bad as I thought. And that's when our higher order cognition is starting to come into play. So if we can all, when those moments happen, kind of think back to what allowed us to get into either of those states, it can sometimes help us get to a quicker place of having a calmer, thoughtful response and being able to move forward. Not that the anxiety is bad, but it's helpful sometimes to be able to move through that, in a quicker fashion.
Nice. Yeah, that's a good challenge. I will do it myself for sure. So yeah, I guess that's it. Thank you very much, Dr. Addy, for being in the show. Thank you for everything you've been doing for the neuroscientific community to help others in your research with everything that you're finding out. And yeah, it was a great talk. Would you please share with us your lab's website and your Twitter username?
Yeah, I'd be happy to. And I also just wanted to say thanks so much for having me on the show. I really appreciate you reaching out. And this conversation has been a lot of fun. You asked great questions and some of the $1 million questions and things that we're still struggling with. So I hope
left
that
without
those
answers.
We're still working on it. But I hope those have been helpful for folks to hear as well, to really know what some of these big challenges are for us as a field and as a neuroscience community. So yeah, I do have a lab website, Addy Lab at Yale. If you put that in a Google search, you'll be able to find it pretty easily. And we do have a lot of videos on there that are related to both to neuroscience lectures, if you want to hear more about that, and also some of the community events that we've done on the intersection between neuroscience, mental health, faith, culture, and social justice. So I think those are conversations folks might be interested in jumping into. I do also have a Twitter handle at Dr. Nii Addy, so DrNiiAddy. And you can see some of the things I've been involved in, some of the commentary that I've been trying to contribute in terms of some of these ongoing conversations.
Thank you again. I appreciate you being here. And I hope to talk to you again soon.
Yes, that'd be great. I would love that.